How's it going, guys? My name is Ramon Lopez. I'm gonna be talking about World of Dance. Since it's next year, I'm gonna be planning my trip, and here are some equations that I'm gonna use during my trip. Alright, since I'm going to be driving, I'm gonna talk about distance. I'm gonna solve distance, my rate, and time. I'm also solve for my average speed and my average velocity. And here are some kinematic equations that I'm also use during my voyage. Alright, I'm getting ready to head to LA. As you can see, I have about half a tank of gas, which I'm pretty sure is gonna let me get there with this half tank. Then after that, I'll probably fill it up once I get there full. Alright, we made it to LA. We're out here at LA in World of Dance. Yeah. Let's see what's cracking. There's a lot of dancers out here. Probably not the best one, but I'm gonna still bust out. Let me get my ticket ready. Which is right here. When I was close to LA, my car speeded up from 29 meters per second to 34 meters per second for 6.5 seconds. After that, I took the exit and my speed changed from 34 meters per second to 20 meters per second in 5 seconds. Then before reaching the stoplight, my speed changed from 20 meters per second to 0 meters per second in 4 seconds. And to solve this one first, you do the same thing. You find the acceleration, and since we already know what the final velocity and initial velocity is, which is 29 initial and 34 final velocity, and we know time, which is 6.5 seconds. After that, you get 0.77 meters per second squared, and that's your acceleration. Now to find distance, this is the equation: d equals initial velocity times time plus 1/2 times acceleration times time to the second power. And then initial velocity is 29 again, time is 6.5, acceleration 0.77 since we found it right here, time is 6.5 again, but this time to the second power. And 29 times 6.5, it turns out to be 188.50, and 1/2 times 0.77 times 6.5 to the second power is 16.27. And after you add these up, you get 204.77 meters. All right. And for the exit, which I took right here, it's this one: 34 meters per second to 20 meters per second in 5 seconds. We have both again, the initial velocity, which is this one, and final velocity, which is this one. So we plug them into the equation where you solve for acceleration, and it's 20 minus 34 divided by 5, and that equals -2.8 meters per second squared. And the reason it's negative is because it decreased, the speed decreased. To solve again for distance, you get initial velocity times time, which is 5, plus 1/2 times -2.8 acceleration times 5 to the power of 2. And then 34 times 5 turns out to be 170, and 1/2 times -2.8 times 5 to the power of 2 equals -35, and 170 plus -35 equals 135 meters. And then when I was reaching the stoplight, I change speed from 20 meters per second to 0 meters per second in 4 seconds. And the initial velocity is 20. And the final velocity is 0 since I stopped the car. Total 0. And time is 4. And after you do this, it's equal to -5 meters per second squared. Again, negative because you decreased speed. And again, solving for distance is initial velocity, which is 20, times 4 time plus 1/2 -5 plus 1/2 times -5 times 4 to the power of 2. 20 times 4 is 80. 1/2 times -5 times 4 to the power of 2 is -40. And you get 40 meters. So in total, with all this, I added up 204.77 meters when I was close to LA. When I took the exit, which was 135 meters for distance, and the stoplight, which was 40 meters for the distance for this one. I added up all the distance, and this was my total distance, which was 379.77 meters. If I'm heading to the Bay Area at 29 meters per second for 10,800 seconds, what is my acceleration at distance going to be? So I use the same equation to find acceleration, and the final velocity is 29. Since we don't know what the initial velocity is, we put 0. And you divide it by time, which is 10,800, and you get 0.00268 meters per second squared, which is acceleration. After that, you solve for distance by 29 times 10 to the 10,800 plus 1/2 times the acceleration times time again, but this time to the power of 2. 29 times time is 313,200 plus 156,297.60. And after you add these up, you get 469,497.60 meters. We're out here at Willow Dance in Hawaii. It's hot. I'm gonna get naked and swim in the water right now before I go dance. I have my ID right here. Let me just scan it real quick. So I guess I found out it was a fake ID. I don't like my mom anymore because she was the one that did it. Never mind, leave that. It cost $25. I just wanted to get wet, but no. It's already open. I just wanted to get wet, but no. But good thing my grandma has a pool, but I hope she doesn't get wet with me. Alright, since I'm gonna be going to Hawaii for roller dance too, I'm gonna be going from Friday to Sunday. My plane ticket is gonna be $667. My hotel is gonna be $278 total with the 2-night stay. That's the total. Transportation, since I can't take the car with me on the airplane, I'm gonna get the bus for $2.50. And my total for those days is gonna be $20. For food, I'm gonna spend $65. And for the Willow Dance ticket, I'm gonna spend $42.50. And extra money that I'm gonna take is $250 just in case I want to buy something. And my total cost for my Hawaii trip is gonna cost $1,322 with 50 cents. We're out here at Vegas. I think that's the door. I'm not sure how to say Vegas. I parked in the wrong parking spot, but alright, let's do this. If I am going to Vegas at 29 meters per second for 10,000 seconds, what is my acceleration and distance going to be? 29 meters per second is our final velocity, and The initial velocity is 0, so you wouldn't know what it is. And you divide it by time, and you get 0.0029 meters per second squared. After that, you solve for distance using the same equation. Initial velocity is 29 times time plus 1/2 times the acceleration times time to the power of 2. 29 times 10,000 equals 290,000. And this turns out to be 145,000. And when you add these two, you get 435,000 meters. And then for the next 65 seconds, my speed will change from 29 meters per second to 31.29 meters per second. What will be my acceleration and distance? A equals 31.29, which is our final velocity, and 29 is our initial velocity since we started with that one. You divide it by time, which is 65, and you get after this you get 0.0352 meters per second squared. You solve for distance again. The initial velocity is 29, not this one because this one's final velocity. You multiply it by time plus 1/2 times the acceleration and time times to the power 2. 29 times 65 is 1,885, and 1/2 times acceleration times time to power 2 is 73.93. When you add these together, you get 1,958.93 meters. And then again, my speed will change from 31.29 meters per second to 20.11 meters per second for 75 seconds due to the route change, because I'm gonna have to change routes. What is my distance during this period going to be? To solve for acceleration, we have both final velocity and initial velocity. Is 20.11 minus 31.29 divided by 75, and that equals negative 0.14 meters per second squared because you decreased the speed. And for distance, you solve again with initial velocity 31.29 times time 75 plus 1/2 times acceleration negative 0.14 times 75, which is time to the power of 2. 31.29 times 75 equals 2,346.75, and 1/2 times acceleration and time to the power of 2 is negative 393.75. And when you add, well, not add because it's opposite sign, so you're going to subtract, but when you subtract these, it's going to equal 1,953 meters. Then for my last route change, I will have to change routes for the last time, and I do that. When I do that, my speed will change 20.11 meters per second to 13.41 meters per second for 70 seconds until I reach my destination. What will my distance be? To solve for distance, again, we have to solve for acceleration first, and we already have those two. Final velocity is 13.41, initial velocity is 20.11, and time is 70. After this, doing this, you get negative 0.09 meters per second squared. That's your acceleration, and it's decreased because you decrease in speed. Solving for distance, initial velocity is 20.11 times 70, which is time, plus 1/2 times negative 0.09, which is acceleration, and time to the power of 2. 20.11 times 70 is 1,407.70, and 1/2 times acceleration and time to the power of 2 is negative 220.50. When you subtract these two, again, they're opposite signs, so you subtract. So it's going to turn out to be 1,187.20 meters.
My man Boogie Frantic, 111.